Okay, well, thank you everyone for attending. This work actually did begin with looking at what was supposed to be a very basic approach to dealing with preferences, and it sort of became apparent that it looked like a good model for deontic reasoning. So by way of motivation, we can note that, well, we're an AI. Agents are going to need to plan, they're going to need to act in order to accomplish their goals and their aims. But moreover, and especially these days, in conformity with various social, moral, ethical criteria, there should be things they do or things that they're forbidden to do, even though they can physically do this. So this area has been looked at under the guise of deontic logic, which is the branch of logic dealing with these notions of obligation, permission, et cetera, et cetera. I'll refer to deontic logic per se, but there's many approaches that would fall outside of a logic per se, and that would include this one here. So we can note lots of work in the area with many, many different approaches. A pretty standard logical approach is to provide some sort of a modal logic with, for example, a unary operator that might say it ought to be, or it's obligatory that something, or perhaps a binary operator saying that, well, under the condition psi, it ought to be, maybe it's obligatory that phi. We can note that specifying a satisfactory formalism has proven to be, and is, I would say, very challenging, with lots of issues dealing with notions of conflicting obligations, specificity, obligations in the case of other violated obligations, and so on and so forth. Where we're taking as a starting point is the observation that I believe was first made by John Horty, that deontic reasoning exhibits non-monotonic aspects and really can be seen as an approach dealing with non-monotonic reasoning, in particular with factual detachment. So here's an example of his, slightly rephrased. You're out, and well, obviously you should not eat with your hands. Although if you're eating pizza, then perhaps you should eat with your hands, or in a variant, one may or are permitted to eat with their hands. And in any case, you should be using a napkin. So looking at these assertions, some things are pretty clear. We would want to apply the most specific rules. So eating pizza would overrule just generally eating as far as the hands go. Irrelevant information shouldn't affect things. If it's a Thursday and you're outside because of a pandemic, things still apply. And in the case of violated rules, other rules should still apply. If there's no napkins, then you're still eating with or without your hands, as guided by the other rules. So the overall approach here is to provide a basic, justifiable, implementable approach to deontic reasoning, in particular notions of obligation and permission. As far as this talk goes, I'm only going to talk about obligation. The paper talks about permission, which really formally ends up being a restricted case of obligation. So just talking about obligation. Here's the setup. We begin with some set of rules of the form phi arrow psi, read if phi is true, then psi is obligatory, should be the case. These things are just formulas in some underlying logic. I'll be dealing with propositional logic, but the idea is the underlying logic could take care of other notions, such as time. So if something's true now, then later on you should do something, and so on and so forth. But one way or another, the rules express conditional obligations. So we've got a bunch of rules. We also have some contingent information, I'll call gamma. So it happens to be the case that you're out and you're eating pizza, for example. And what we want to determine is the best that can be attained in those circumstances. What should be the case? What are the preferred circumstances? So, well, an easy example, you're eating pizza Thursday night, you don't have a napkin. Well, it should be the best state of affairs is where you're eating with your hands. Okay, so two approaches are developed and shown to be equivalent. I'll, of course, sketch through them subsequently. Call it a semantic approach, where given the set of rules, we determine a pre-order on worlds. And as usual, minimal worlds are better. So given a set of rules, if we want to see what should be the case, given that gamma is true, we look at the gamma minimal worlds, and that characterizes the best states of affairs in the case of gamma. A syntactic approach is we would start with information contingent concerning the domain, gamma, and we look at certain to be described maximal subsets of these rules. Actually, it's transformations of these rules, and this formula will express what should be the case. Okay, so if we look at the semantic approach, these rules induce an ordering, this is on the next slide, over possible worlds, over models. And here's the fundamental intuition. Intuition number one, I suppose. All other things being equal, you've got some rule, psi arrow, phi arrow psi, a phi implies psi world is preferred to a phi and not psi world. This, some people might notice, is a bit different than what you see in conditional logics. I'll return to this at the end of the talk. If we have conflicting rules, I'll say what I mean by conflicting on the next slide, we apply the more specific rule, okay? We come up with a ordering, partial pre-order over models, and then given gamma, we look at the minimal gamma worlds in this ordering to characterize what should be the case or the best that can be attained. Okay, so sketching through the semantic approach, we'll define, I'm not sure how to pronounce this, so I won't, R2 something R1, R1 dominates R2, just if the antecedent or the body of R1 implies R2, and the heads or the consequences are jointly inconsistent. We take the strict part of this, and so what we'll be dealing with is one rule here, R1, strictly dominating another, R2, and given this, we come up with this thing here. So for a world W, F sub M WR is those rules that are falsified, and if you've got a falsified obligation, that's a bad thing. So these are the rules that are falsified, the body is true, the head is false, and any rule that dominates it is, in a sense, inapplicable. Its body is false at that world. So we collect these things, and then we just define our preference between worlds based on subset containment for these maximally falsified sets of rules. So that's it. That gives us our partial pre-order. And then we can, as usual, determine or define an inference relation. So gamma snake psi, just if the minimum gamma worlds are contained in psi worlds. Okay, computational approach. Second approach, we've got a set of rules and we transform them so that we have specificity compiled into the antecedent. So for each rule, R super, triangle on its side, I suppose, is the original rule expressed as a material counterpart. So here we've got a material conditional, and also in the body, we have the assertion that any rule that dominates it, its body is false. So we've got this transformation of rules. Given this, and given a formula gamma expressing contingent information, we take the set, we look for the set of maximal subsets of these rules consistent with gamma. Okay, so from this, we've got this set of subsets. We take for each subset their conjunction. We disjoin the result. We conjoin that with gamma. So basically, we've now got a formula that has gamma in it, and it's got a disjunction of these maximal subsets. So this is a formula that expresses the best that can be attained given gamma and given R. Okay, few results. We can observe, it's a pretty trivial observation, that snake is a preference relation. But unlike the KLM approach, we have a single ordering for a set of rules. So among other things, irrelevant properties are taken care of. We have the result promised earlier. The set of models of this formula for a given gamma is exactly the minimum gamma worlds in this preference ordering. So a result comparable to soundness and completeness, or if you like, a representation result. We get that complexity is reasonable. It's at the second level of the polynomial hierarchy, this for entailment. So the same as other related approaches for non-monotonic reasoning, belief change, et cetera, et cetera. The paper's got a bunch of examples, and I'll claim that the various paradoxes examples are handled correctly. But I should say, in my opinion, so there's some disagreement here, particularly regarding the so-called Forrester paradox. I could note, for example, that Leon Vandatory isn't convinced by this. So anyway, it's a truth in advertising footnote here, if you like. Okay, a couple of examples, pretty simple examples. Here's our pizza example. It has the expected naive encoding. I won't read through it. What we get is the best worlds in the ordering are given by, well, if you look at this, you should have a napkin, N, and either you're eating pizza with your hands or you're not eating pizza and you're not using your hands. We also obtain, for example, that in the case where you're eating with your hands, but you're not eating pizza, maybe you're eating mashed potatoes with your hands, you should still be using a napkin. The napkin world is preferred to the non-napkin world. Chisholm's paradox, you ought to help your neighbor. If you help them, you should tell them. If you don't help them, you shouldn't tell them. And contingently, you decide not to help your neighbor. Here's the encoding. What do we obtain? Well, we do obtain, for example, that the very best thing is you help your neighbor and you tell them. But if you don't help your neighbor, then it's better not to tell them than to tell them you're going to do so. I'm not sure how I'm doing on time. My watch has gone to sleep, so let me know if I should be finishing soon. One thing that's a little bit to the side, but I think it's interesting, is this note on specificity I mentioned. So what we have is, for a conditional obligation, world W1 is preferred to W2 if the material counterpart in W1 holds and it's falsified in W2. This is in contrast to the usual normality interpretation, where we could say in W1 the rule is verified and W2 it's falsified. We've got this, and of course it has implications. If we consider our pizza example, don't eat with your hands. If you're eating pizza, eat with your hands. Our notion of preference yields in the best or the most desirable worlds, you're eating pizza if and only if you're eating with your hands. If we gave this a normality interpretation, we'd get in the most normal worlds, one isn't eating with the hands and pizza isn't eating. So from a notion of obligation, this would say that, well, you shouldn't be eating pizza, which really, I would claim, is the wrong interpretation. The claim being that if we're dealing with deontic concepts, only the first interpretation is appropriate. Okay, bunch of conclusions. I won't read through them. I'll just leave this hopefully up. I'll just simply note that in the paper, I also handled qualitative and quantitative weights. So if the rules have different importance, I'm interested in employing this in particular in an action theory in a different direction. I've done work with Jens Claassen dealing with deontic concerns, but in particular, we'd like to work this stuff into some sort of a planner. Okay, so I'll stop there. So thank you for your attention, and I'm happy to take any questions should there be any.